Hello! Today I'm going to explain how to do problem 24 in section 3-4 of my calculus book, which details derivatives and their uses in a real-life context. The problem reads as, Chuck stands atop a cliff. He throws his math book into the air with an initial upward velocity of 20 meters per second. As a result, its height, h of x, in meters above where he threw it after time x in seconds is shown as h of x equals negative 5x squared plus 20x. And it also starts with part A, which says, the upward velocity of the book is the derivative of height with respect to time. Write an equation for the upward velocity. The question tells us to find the derivative of the given height function. To obtain the complementing velocity function, we can use the power rule to get v of x, which is the velocity function of the height function. And the velocity function is equal to negative 10x plus 20. Which we can graph alongside our h of x function over here. Next is part B, which asks, how fast was the book going at time x equals 3? Was it going up or going down? And to explain. To find how fast the book was going at the 3-second mark, we just substitute 3 for x in our velocity function, which yields negative 10 meters per second. This answer means that the book is moving at 10 meters per second in the downward direction, which is indicated by the negative sign. We can see this on the h of x graph where the book is traveling down at x equals 3. Part C reads as, at time x equals 3, was the book above or below where Chuck threw it, and how far? To find what the height of the book was at x equals 3, we substitute 3 for x in the h of x function. This yields an answer of 15 meters. Since Chuck is positioned at point 0, 0, the vertical distance of the book is 15 meters above him. Lastly is part D, which reads as, at what time was the book at its highest point and how do you know? To find the maximum point of the book's height, we can use the velocity function to find where the book's velocity equals 0. We know that this indicates the maximum height because of physical properties of things when they're being thrown. Solving for x using the velocity function yields a time of 2 seconds after the initial throw. You could also trace on the graph with a calculator for the maximum of the parabola, or use the quadratic formula for it algebraically, but this is a little bit simpler. And that is how you solve problem 24. Please leave any questions or comments below and I'll try to get back to them. See ya.